Let me know when we're live.
It's very hard.
All right, let's get us started. Thanks for coming today. I know it's a very busy month for both the philosophy department and HPS. So I'm glad to see you, all of you here today for the Adolf Greenbaum Memorial Lecture, which is part of the annual lecture series. So before introducing our speaker today, let me say a few words about Adolf Greenbaum. So Adolf Greenbaum was the first Andrew Mellon Professor of Philosophy here at Pitt. He joined the philosophy department in 1960 when he was hired away from Lehigh University and he was in the philosophy department until his death in 2018, in November 2018. It's fair to say that he was a world preeminent philosopher of physics of his generation, and he made extremely important contribution to our understanding of space and time, among many other issues in the philosophy of physics. But it's not the only reason why we are celebrating Adolf's memory. Another one is that he was also an institution builder. And it's one of the many remarkable aspects about Adolf. Maybe it's a slight exaggeration, but only a slight exaggeration, that he created philosophy here in our institution and made philosophy what it is here at Pitt. Among many other things, he founded the Center for Philosophy of Science, which I'm directing now, in 1960, and he remained the director of the center until 1978. He also created the annual lecture series, which is we're part of that series in 1961. So it's the 54th occurrence of that series. I'm told, I don't know whether it's true, but we're going to believe it's true, that is the longest philosophy series, continuous philosophy series in North America. It might not work, it might not be true, but let's pretend that it is true that we have. His work includes very important books, such as The Philosophical Problems of Space and Time in 1963, and somewhat closer to my own research interest, The Foundations of Psychoanalysis, later on in his career in 1984. So we are honoring his memory, his work, as well as his legacy of prolific and profound contributions to the field of philosophy and also to Pitt. And to honor his memory, we created this lecture a few years ago, thanks to a very generous gift by his daughter, Barbara Greenbaum, and her family when Adolf passed away a few years ago. And we're extremely grateful to Barbara for that gift that has allowed us to remember Adolf's contribution to philosophy and to Pitt on a yearly basis. And that award has been given, that lecture has been given by very prestigious philosophers of science since its creation a few years ago. And that tradition will not change. Because this year we are delighted to have Professor Alyssa as our Adolf Greenbaum Memorial lecturer. So before introducing Alyssa, let me remind you of a few events at the center in the coming days. We have 2 lunchtime talks next week, one on Tuesday by Karl Höfer here, and one on Friday by Frederick Yaek. So we are all welcome to attend these 2 talks, and then we'll have the break. Well deserved. I think many of us feel exactly that. So today, it's my great pleasure to introduce to many of you Professor Alyssa. I guess many of you are quite familiar with her and her work, but I will say a few words about her. I think many of you know, but maybe not all of you know, that she's actually now professor and chair of metaphysics at LMU in Germany, in Munich. She works mostly, she used to work at Davis, and before that she was at Rochester. She works mostly in the intersection of philosophy of physics and metaphysics on topics such as fundamentality. We're going to hear about that today. Locality in philosophy of physics as well. Quantum theory as well. She has published widely on all of his topics. There's a paper forthcoming, I believe forthcoming, correct me if I'm wrong, is a Journal of Philosophy, and she's published in all the important journals. I will not go through the long list of publication. That's not why we're here for, but I will mention her recent books. She wrote Metaphysical Introduction, which was first published in 2013 and which had been re-edited in 2023 with a second edition. And she also is the author of the well-known The World in the Wave Function, a metaphysics for quantum physics. That project, I understand, is part of a book. So that's going to be Alyssa's new book. And so we're looking forward to hear more about the project and hopefully soon to read the book. Alyssa, floor is yours.
So much. Thanks, Edward. That was really a kind introduction, and it's really an honor to be giving this lecture. My first year of grad school, Adolf Grunbaum gave a lecture, and I mean, I was definitely too shy to talk to him, but yeah, this is a really honor to be here, and thanks for coming. I know, yeah, it sounds like you have had a lot going on. Maybe you probably always do. But thanks for being here. I'm really excited to get feedback. So this is a book, The Fundamentality of Physics. It's not going to be called Without Completeness, just The Fundamentality of Physics, that I just finished writing the end of the new year, or the last year. I was very happy because this was like my New Year's resolution to finish the book for the past like 5 years. This is a project that I've been working on since my dissertation. And yeah, so I'm very happy to get feedback. I'll be presenting mostly the middle part of the book, but in the beginning, we'll have a little from the beginning. So let me just give an overview of the plan. Actually, you know what, first, let me just give you a few sentences about what the book is about as a whole. So what I'm really trying to do here is articulate and defend a sense in which we can say it is established that physics is fundamental. I understand not everybody here is going to be agreeing with this or not wanting to say that physics is fundamental. Okay, I'm a metaphysician. I'm very interested in fundamentality, and part of the reason why I got interested in that was because I did think physics is fundamental in some important sense. So I'm trying to articulate this sense, but the reason really for doing so that's motivating me in this book is to say that there is something special, metaphysically special, about our actual physical theories that have been developed and tested that can underwrite the special social status that physics has. So when I say the special social status, let me just tell you what I have in mind, what I'm trying to defend and underwrite by defending the metaphysical fundamentality of physics, so that you can have that in your mind throughout the talk, even though this social standing is not something I'm going to be defending in this lecture today. So, I mean, there are several things. One, you know, famously, the physics experiments, like the projects at the LHC, the many neutrino experiments, telescopes are very expensive, and they're funded by taxpayer money. Often the public that's funding this doesn't know or care about the research that's being conducted there. Physics forms a very important part of education, K through 12 education. Science teachers in K through 12 have to learn this material and teach it to students, spend time teaching it when they could be teaching other topics. And some of our most promising students that we have in our classes go on and decide to spend their careers working on developing these theories and testing them. And so, you know, we can ask, like, is all of this justified? All of these resources, these financial resources, these resources of time and personnel, like, should they be going towards developing and testing and spending time learning and teaching physics? And I think, yes, it is justified. But the argument for that, I think the best argument for that is going to run through some claim that physics has a special ontological status that's metaphysical. And so that's the motivation for the book is, all right, can we give a legitimate sense in which physics has a special status of being metaphysically fundamental? That's, yeah, that we can say that's just established fact. Physics isn't just another special science. It's fundamental. And in virtue of that, it is worth developing it, testing it, and so on. And so I'll come back to this at the very end once we see what the way I think we ought to understand the fundamentality of physics, whether I'll gesture at why I think because physics has that status, it is worth teaching it, it is worth funding it, it is worth throwing money at it. But yeah, that's something maybe we can discuss more in the Q&A if you're interested in, but it's not really what I'm doing today. So let me say what I am doing today. So the plan of the talk is in the first slide, the first maybe like 15 minutes, I'm going to be talking about what I do in the first part of the book. And that's mainly to introduce the standard way people want to interpret the claim that physics is fundamental today in philosophy, in metaphysics, in philosophy of mind, in philosophy of science to some extent, and then to argue against that. So the standard kind of interpretation of the claim that physics is metaphysically fundamental is that physics is ontologically complete in a way that I'll fill in a little bit. And what I want to say is, maybe it has that status, but that kind of interpretation of the fundamentality of physics has limitations. It's not going to really let us do what we want with the claim that physics is fundamental. And so I want us to move towards, in philosophy, I want us to move towards thinking about the fundamentality of physics in a different way. And so I'll propose an alternative conception, and really this alternative way of conceiving the fundamentality of physics isn't just coming out of thin air. It's not something that, I was so creative and invented. It's just the way when you read physicists waxing philosophical about their theories, and they say like theories like the Standard Model have this special status, this is what they say the status is. So I'll just say the account is that physics is fundamental not because it provides because it provides a complete set of ontological bases, but physics is fundamental because it provides the most comprehensive and deepest set of ontological bases than any other science. So I'll put that on the table. I'll give you some kind of passages from physicists that are saying things like this to show you why where I'm getting this from. But then a lot of the work, the meat of the talk is going to be to explain what I mean by saying that physics provides ontological bases that are deeper and more comprehensive than any other science. So I'll talk a little bit more about what's meant by depth. I'll talk a little bit more about what's meant by comprehensiveness. Actually, the depth claim is the more challenging one. So especially given the fact that I'm saying, we're just going to be starting early on in the paper by acknowledging that our current physics isn't complete. There is going to be a challenge in explaining what it could mean to say that physics provides ontological bases that are the deepest. So I'll discuss the way that challenge comes up, but then we'll resolve the challenge and I'll conclude. So that's the plan. So let's get started. So the claim that physics is fundamental really occupies a very central role in philosophy today. In metaphysics, definitely in philosophy of mind, but also throughout many areas of philosophy, metaethics, philosophy of language, philosophy of math. And here, usually, the main claim of interest isn't immediately always that physics is fundamental, it's physicalism. But today, although historically people sometimes would understand physicalism as the claim that the world is just the way physics says it is or something like that, today, usually when philosophers want to articulate what physicalism is as a doctrine, they'll say, it is not the claim just that the world is the way physics says it is, but that physics is fundamental in some metaphysical sense. And so that in turn, that claim that physics is fundamental will get cashed out in a variety of ways. So for example, as the claim that all facts or entities supervene on the physical facts or entities. Some people don't like talk of supervenience, so they'll say, no, really the claim that physics is metaphysically fundamental or physicalism should be understood as a realization claim. All entities are realized by the physical entities. So for example, Andrew Melnick in his Physicalist Manifesto wants to understand physicalism in this way. Sidney Shoemaker also did too. They said, let's not talk about supervenience for realization. And then very commonly in metaphysics today, people like to talk about grounding instead. And so they'll say, people like Jonathan Schaffer, Shramik Dasgupta will interpret physicalism or the claim that physics is fundamental in this way. All facts or entities are grounded in the physical facts or entities. For my purposes, in the book, I'm not really interested in getting in, to these disagreements about whether we should talk about supervenience or realization or grounding or even reduction or any of those. What I'm really interested in is what ties all of these together, in that they're all saying, in some sense, physics is ontologically complete. It's ontologically complete in the sense that it provides a complete set of ontological bases for all facts or entities, right? Whether that's a complete set of grounds or a complete set of supervenient species or a complete set of realizers, it's a complete set of, let's just say, ontological bases in some sense. And that has been, very, very common. Again, it motivates a lot of projects of how could we understand the existence of phenomenal consciousness? How could we understand free will? How could we understand the existence of normativity and so on, if this is the case? But what I want to say, start from is, how could we be resting all of our so many of our philosophical projects on that claim when it's just false? It's just false that our current physical theories provide a complete set of supervenient species for all facts or entities, or a complete set of realizers, or a complete set of grounds. So there's an answer to that question, which is that when philosophers are usually claiming that they're physicalists or that they believe that physics is fundamental in a metaphysical sense, they're not saying that our current physics is fundamental, that our current physics provides a complete set of supervenient species or realizers or grounds for all facts or entities. What they're claiming instead is that there's some future physical theory, or if there won't be because we're too stupid or we destroy the planet and we can't move forward, the experiments get too expensive or whatever, there's at least some possible ideal physical theory, and that theory provides a complete set of ontological bases for all facts or entities. So that's with the exception of Andrew Melnick, who, his name's missing here, but with the exception of Andrew Melnick, who says, oh, no, my physicalism is the view that current physics provides a complete set of realizers for all facts or entities. Most metaphysicians, most philosophers of mind, most philosophers who want to defend the fundamentality of physics will say, the claim is that there's some physics, some physical theory, even if we don't have it now, we'll have it in the future, we could have it, and that theory provides a complete set of ontological bases for all facts or entities. So what I want to do here is say, well, first of all, I am skeptical of that. This might sound strange because I will say I am a physicalist. I do believe physics is fundamental, but I am skeptical of whether it is true that there ever will be or could be a physics that provides a complete set of ontological bases for all facts or entities. But set aside that. I talk about this in the book, but let's just set that aside. I don't need that for today. Even if you think that is true, what I want to do here just first to kind of get you in the mood for maybe another interpretation of the fundamentality of physics is to say there are many roles for a claim that physics is fundamental where it really should be a claim about current physics. Or more specifically, it really should be when you're saying physics is fundamental, this really should be understood as a claim about physical theories that are actually formulated, have been tested, and that we have good reason to think are tracking something correct. And And even though we know these things are incomplete, right? So there is a reason to say our current physics, even if it's not complete in the sense of providing ontological bases for all facts or entities, has some special metaphysical status. And then a reason to kind of, for metaphysicians to, like me, to say, and this is what that status is. Okay, so I'll just talk about 3 reasons for motivating that project. So again, let me just say this. If you are somebody who wants to say, no, when I say I'm a physicalist or I say physics is fundamental, I mean there's some physical theory that's ontologically complete, fine, you can keep saying that. But what I want to do now is just try to motivate you but there is also good reasons to want to articulate a sense in which our current theories, incomplete though they are, have some special ontological status. So the first reason is that often physicalists, or people who want to say physics is fundamental, want to say that their position has some kind of empirical support. So in David Papineau's article, The Rise of Physicalism, what he starts it by saying, physicalism isn't a fad or a fashion. It's an empirically supported position. It wasn't always scientifically supported. He thinks until the mid-20th century, there wasn't really good scientific reason to be a physicalist, but now there is. And I think that this is widespread, even though this isn't something that I have found that much articulated by physicalists. I think usually people want to say, like, look, I'm not a physicalist just because I think physics is cool or I have some kind of physics fetish. I think this is a empirically motivated position. But the concern that I have, and this is something actually Malik also raised in his book, was it's very difficult to see how the claim that physics is fundamental could be empirically supported if it's a claim about a theory that hasn't been even formulated, let alone tested. And so if you think that's right, and you think that any empirical support for the claim that physics is fundamental has to somehow rest on the back of the empirical support of the theories that are being claimed to be fundamental, then you should be wanting to make that a claim about that you're asserting about theories that have been formulated and tested and so on. So that's a first reason. If you want the claim that physics is metaphysically fundamental to have empirical support, then you should be trying to articulate a claim about that's true of current actual physical theories. And that's not going to be that they're complete. The second reason that I think it's worth articulating a sense in which our current physical theories are metaphysically fundamental is if you think about the role that claim that physics is fundamental actually plays in much of philosophy today, you can see it's really not engaging with the features of some unknown, untested, I don't know what, merely ideal maybe physics, but these projects are engaging with features of the physical theories that we actually have and that we have good empirical reason to adopt or support. So if you think about the problem of free will, right? The problem of free will comes about because we have reasons to think that our best physics is going to be deterministic, or if it's going to be indeterministic, then it has such and such features. The hard problem of consciousness, the problem of naturalizing intentionality, the problem of finding a place for normativity in our world. All of these are motivated by saying, look, our physical theories are like this, and they're fundamental. They're giving a fundamental characterization of reality. How could a world that's fundamentally like this, the way these physical theories say they are, possibly also have phenomenal consciousness, possibly also have normativity in it, and so on? Possibly could have states that somehow point outward. That's all of these problems are motivated by considering the character of our actual physical theories that we have good reason to believe. And so again, given the fact that so many of us spend like our careers being motivated by problems about, this assumption that physics is fundamental, it looks like, yeah, we want to understand that, we should want to understand that claim better in a way that it actually motivates these projects. All right, so that's the second reason. Then the third reason is just coming back to what I was mentioning at the beginning, which is that physics does have a special social standing among the sciences. And it seems like if you want to have, well, what Kitcher calls a well-ordered science, so you want to have a science that is structured in such a way that it aligns with the kinds of things the citizens who are funding the science care about, you should want to have some kind of argument that physics deserves that funding. What I think is that the best way to make that kind of argument is to say, look, the problems that are the most important that we, as the citizens who are funding this science, think are the most pressing problems that we need science to solve will be addressed better if we're teaching physics to people, if we're developing these theories and testing them. Then we need to have a kind of argument for why doing that, why teaching physics, why funding research in physics is going to get us success at addressing these problems. And what I think is the best way to make that kind of case is to argue in the first place that physics has this special metaphysical standing. But again, you're not going to make that case by talking about the special metaphysical standing of some physics that we don't know, because though whatever that physics is that is going to be complete, that's not going to be the physics that we're actually saying that should be taught in the schools, right? Or that should be taught at the universities. That should be tested. Those theories, those frameworks, those paradigms should be developed because we don't know what those are. Okay, so for all of these reasons, I want to say it's worth developing an account of what is ontologically, metaphysically special about our current physical theories, even though at the same time we can recognize that they're not complete. So what I'm looking for here is a sense in which our current physics is plausibly metaphysically fundamental. So I say plausibly, when I say plausibly, I mean a sense in which our physics is fundamental that we can say is supported by our best science. And it's also going to be an ontological status. So when I say that physics is fundamental, I'm not saying that it's epistemically fundamental, right? You can't have justification for any other claim in any other science without first being justified in the physics claim and then deriving from that. I'm not saying that it's fundamental in the sense of being more important than any other science. All I'm saying is that it's metaphysically fundamental. It has a special ontological status. And the proposal is going to be that current physics is metaphysically fundamental, not in providing a complete set of ontological bases for all facts or entities, but instead in providing deeper and more comprehensive ontological bases than any other formulated scientific theory. All right, I'll have this statement of it again, but let me just try to start by saying a little bit. I had mentioned earlier, I'm not just pulling that out of thin air. I think this is a kind of feature of some of our best supported physical theories that has been defended by several physicists when they wax philosophical about their theories. So I'm going to put a few quotes up here to try to just show you this. 1 second. So all of Richard Feynman in his book in the 80s, where he was giving the kind of popular description of quantum electrodynamics, and Simon Weinberg in the 90s in his Dreams of Final Theory, where he was trying to give a kind of motivation for supporting really big, expensive physics projects, in particular at that time, the superconducting super collider project that they were trying to build in Texas. And then Sean Carroll also, in his book from maybe like a decade ago, the Big Picture, where he's defending not physicalism, but what he calls poetic naturalism. They all discuss our standard model, so the quantum field theories making up the standard model, but also general relativity as having a special ontological status among the sciences. And the way I see, I'll put some quotes up, but I think what they're arguing here is really not that the standard model has a special status, that it's ontologically complete. It's not ontologically complete. It doesn't address all scales at the very least. But what they're saying is that it provides accounts of the world, and I think plausibly these are ontological accounts of the world, that are deeper and more comprehensive than that of any other science. So here's Feynman in QED, says, most of the phenomena you are familiar with involve the interaction of light and electrons, all of chemistry and biology, for example. The only phenomena that are not covered by this theory are phenomena of gravitation and nuclear phenomena. Everything else is contained in the series. So you're seeing this comprehensiveness claim here. He also does talk about, and there is no other theory that explains these phenomena in turn. Doesn't mean it's ultimate, the end of the story, but it's the deepest that we have now. Weinberg is also especially clear. So let me set this up a little bit. So when Weinberg talks about, he does explicitly use the language of fundamentality and wants to say, at some point he says, why did condensed matter physicists complain, when we say that physics is fundamental? He says, because it is, or why the standard model is fundamental, because it is. So what he has in mind when he says the theory is fundamental, I think it's best explained in the second chapter of the book, which he calls On a Piece of Chalk. So it's called On a Piece of Chalk because he's kind of mirroring this earlier lecture by Thomas Huxley, but I think you can kind of imagine him. We don't have this anymore, but it used to be when you gave a lecture, there was a chalkboard and a piece of chalk that you could pick up. So you can imagine him almost just like picking an object at random and saying, let's consider any kind of feature of this object that we want to consider and ask, why is it like this? So he does this with the chalk. He says, it has this observable feature. It has this color. It's white. Why does it have this? Why does it have this texture? Why does it have this chemical composition? The reason why he uses the piece of chalk, the reason Huxley does and finds it interesting, is we could also talk about the fact that this chalk is made up of the skeletons of animals and ask about those features and explain those. Whatever question we start with, about whatever object he had picked up, whatever feature of it we wanted to ask about, even if it's a biological feature, we can trace back by asking a series of why questions, a series of arrows down, down, down. Ultimately, they'll all come and converge at a common source, and that's the standard model. So he says, this is at the beginning of that chapter on a piece of chalk, but it's the conclusion. By tracing these arrows of explanation back towards their source, we've discovered a striking convergent pattern, perhaps the deepest thing we have yet learned about the universe. So again, the idea is physics, the standard model, is comprehensive in that practically anything you want to ask about, you'll be able to get an understanding of it, ultimately in terms of the standard model, and there's nothing deeper. And then you see something similar in Carroll. So Sean Carroll talks about the core theory. This is the standard model of particle physics and the standard model. And again, this is very similar to Feynman. Almost all of the phenomena we encounter in human experience is accounted for by a very small number of ingredients: atomic nuclei, electrons, gravity, and electromagnetism. If you want to describe what goes on in rocks and puddles, pineapples and armadillos, that's all you need. The laws of physics underlying everyday life are completely known. So again, the idea is that, is this the final theory? Is this the theory of everything? No, but you can explain a lot, and it's the deepest that we have. And so I think that is a very special ontological feature of our current physics. And therefore, as metaphysicians, when we're interested in fundamentality, most of the discussions of the fundamentality in metaphysics are motivated by saying, oh, let's try to understand better physicalism and these other positions and positions like that. I think it's worth saying, okay, well, what does it mean to say physics is fundamental? Okay, so this is a proposal. Current physics is metaphysically fundamental in the sense that it provides ontological bases that are deeper and more comprehensive than those of any other scientific theory. So really my interest in this, well, in this presentation, but in the book more broadly, is with the fundamentality claim and not physicalism. But I just want to take a minute just to say something about physicalism and how this connects to what I'm going to be talking about, or what I'm really most interested in, the fundamentality of physics. So as I mentioned earlier, most philosophers understand physicalism just as the claim that physics is fundamental. So these two things are run together, I mean, intentionally. Physicalism is the claim that physics is fundamental. The claim that physics is fundamental is physicalism. But it's just worth noting, if you understand the fundamentality of physics in the way that I'm proposing, you can't put those together, because a dualist can perfectly well accept that physics is metaphysically fundamental in this sense. In fact, you know, if you read David Chalmers, Dualist in the Conscious Mind, or Constructing the World, you see he's saying always, no, physics explains a lot. I don't know if he's going to say, I mean, I have an argument at the end of this presentation that'll convince, I hope would convince him to say that physics is also the deepest of all the sciences. But I think he would agree with the claim clearly that it's the most comprehensive. So, okay, it's this, what are we going to say about this? I think this is actually a virtue of the account, that the claim that physics is metaphysically fundamental, when it's understood in this way, is a claim that both physicalists and dualists could accept. Because I think it is worth, at least if you think, I mean, maybe, I know I haven't said like anything to convince you of this here, but if you did think that it was important for some reason to defend the fundamentality of physics, it would be nice to be able to say, look, this is just a scientifically established fact that physics is fundamental. And yeah, we philosophers have disagreements about consciousness and whatever, whether we should be dualists, but that's a debate about something else. That's not this debate. Everybody can agree, even dualists can agree, that physics is metaphysically fundamental in this sense. So that's what I'm trying to do here. Now, what's physicalism? Well, I have a lot to say about that, but I'm not going to bore you with this here. Let me just kind of give you the overview of the idea is, there's one thing to say physics is metaphysically fundamental. Current physics is metaphysically fundamental in the sense that it provides ontological bases that are deeper and more comprehensive than any other science. But then we acknowledge, but it doesn't provide ontological bases for everything, or at least that hasn't been established, right? There's no agreement that we know how, you know, that phenomenal consciousness has an ontological basis in physics. That's just not, that's something we're fighting about now. But then the question is, okay, once you say physics is fundamental in the sense that it provides ontological bases that are deeper and more comprehensive than any other science, now there's a question, should I then be a physicalist? And the way I think about that is, that's the question of, well, now should I commit to, should I use in my projects, should I try to develop theories that only appeal to things that are ontologically based in current physics? Or should I believe that there are more things? Should I believe that there are also things that are not ontologically based in current physics? And frame scientific theories in terms of them, and reason in my daily life by assuming those things exist. If yes, then you're not a physicalist. So those are, physicalism, dualism, those are attitudes that you adopt, but they come kind of after this question about fundamentality. I'm happy to talk about this more, but okay. Now, what I want to do for the rest of the time is try to get clear on what's meant here by comprehensive and deep. And then by the end, hopefully we'll have as clear as we can get in 20 more minutes, and a count of what I mean when I'm saying that current physics is metaphysically fundamental. All right, so I'm going to do comprehensiveness first because it's a little easier than depth. So the comprehensiveness claim is that physics provides ontological bases for more kinds of phenomena than any other science that's formulated today, more kinds of phenomena. And so we saw like a little bit of this in the quotes from Feynman and Weinberg and Carroll. They're all, they're really all focused explicitly on observable features. Well, Feynman and Carroll are more, Feynman especially because he's talking about QED, focused on observable features of objects. But there have been arguments in the history of philosophy of science where people have wanted to go and say, it's not just observable features, but in general, all features of the special or phenomena of the special sciences have ontological bases in physics. So you can, right, so defending this comprehensiveness claim. So very famous paper defending this was Paul Oppenheim and Hilary Putnam's 1958 Unity of Sciences Working Hypothesis, in which they presented this hierarchy of sciences with physics at the bottom. And they wanted to say, yeah, you've got all of these different sciences. You have physics, you have chemistry, biology, the social sciences. And it is a case, whatever science you talk about, so let's just consider economics, you're talking about social groups there, and they ultimately are composed out of more fundamental things that are composed out of more fundamental things, and ultimately that bottom out in fundamental particles from physics. And then more recently, Andrew Melnick in his Physicalist Manifesto gives in the last chapter an argument that's trying to update Oppenheim and Putnam, because I mean, Oppenheim and Putnam kind of give a survey of how these kinds of micro-reductions were carried out across the sciences, but this is by now like 70, something years old. So trying to update this. But let me just give an overview of their style of argument, and then just say a little bit about this and how we can connect this to maybe a more promising argument for fundamentality of physics. But I mean, there is a lot to say about the details of both of these arguments. The overview, the way that both Melnick, and Oppenheim and Putnam proceed is in 3 steps. So the way that they establish this claim that all the entities across all the sciences have ontological bases in physics is first by giving examples of micro-reductive successes. And those micro-reductive successes in general aren't cases where you see phenomena in a particular science being immediately reduced to physics, but it'll be something like you have some kind of phenomena, a biological phenomena, and then you have an account of it in chemistry or something like that. And so they start with all of these micro-reductive successes, and then they'll appeal to, this is not explicit here, but it's explicit in Melnick, they'll appeal to the transitivity of the ontological basing relation. So for Melnick, I already mentioned that's realization. For Oppenheim and Putnam, it's a mereological relation. So something is micro-reduced when it possesses a mereological decomposition into parts at the other science, the phenomena of the other science. And then what you say is, essentially something like, these ontological basing relations are transitive. So for example, if social groups are made of individuals and individuals are made of molecules, then the social groups will be seen to be made of molecules. And so you get some cases where you have phenomena across the special sciences that have been micro-reduced, and then by the transitivity, you can see these phenomena as reduced ultimately or ontologically based in, to be more neutral, the entities of physics. And then the last step is this inductive step, where you say, okay, and then we can, by induction, say all entities of this kind, or all phenomena of this kind, are also able to find ontological bases in physics. So this is roughly the argument that I like, the style of argument that I like for the comprehensiveness claim. I mean, there's one thing to say about this, which is that, of course, these arguments overreach. So both the argument in Oppenheim and Putnam and in Melnick also, though Melnick is much more modest about this. He's like, I don't know, it's tough to get this last step to say all psychological phenomena can be realized by physical phenomena. But they're overreaching, right? And I mean, the main reason that I want to say we should be confident that they're overreaching is that this last inductive step is going to say, okay, you have this micro-reductive success, you have this micro-reductive success, you have this micro-reductive success. Therefore, we can say all of the entities that fall under that kind find ontological bases in physics. But there are phenomena that many philosophers have argued aren't similar in kind to these other things that have been micro-reduced. And so it's very difficult, I think, in the end to inductively establish that everything will have ontological bases in current physics, even if we acknowledge there's been very wide success. So this is why, okay, this is in the end, I want to say physics is comprehensive in this sense, and that's great. Is it complete like these other people that were defending unity of science thought? Probably not. Last thing about comprehensiveness, I just want to emphasize there are a couple of things we should be very clear if we're going to defend the fundamentality of physics and try to say, yeah, physics is not just a special science. It has a special status in being metaphysically fundamental. We have to be very careful, just given the history of these debates about unity of science, reductionism, and physicalism, what we're not saying. So first, we have to be very clear that a claim about the fundamentality of physics or the comprehensiveness of physics is not a claim about eliminativism. Should be relatively straightforward, just because the claim isn't, the claim that I've been making over and over again isn't that so many phenomena reduced to physics, although privately I do like that language. It's that they're ontologically based in physics. And if you say that something is ontologically based in something else, you're not saying the thing that's ontologically based doesn't exist. You're saying it's ontologically based, it exists, and it's somehow constituted or built up out of or realized by this other phenomenon. And moreover, any of the arguments that are going to be convincing, kind of arguments in defense of scientific realism about the phenomena of physics, electrons, electromagnetic fields, and so on, should also be the kind of arguments that successfully establish scientific realism in other domains, special sciences. So I'm not trying to, I just want to be explicit, this isn't an eliminativist position at all. Maybe more importantly to say, it's more important to say that it also doesn't imply in any sense that the physical explanations are always the best. So we're saying that physics is comprehensive. First thing is, this is a claim about ontological bases. It's not a claim about causal explanation. So it's not even saying that anything that you want to explain in a science can be explained by a microphysical explanation. I think we have to take on board all of these arguments that were, in opposition to the kind of unity of science doctrines of maybe the 1950s and 60s by philosophers of the special sciences, showing that very often the right explanation, whether that's a causal explanation or, I mean, Putnam here wanted to say it's not in the special sciences. He said, we're not looking for a causal explanation, we're looking for formal explanations. Whatever you want to call them, I think we need to take on board this work that's showing the best explanation, or even often an explanation, isn't the microphysical explanation. But that can be accepted while at the same time allowing that these phenomena have ontological bases in physics. So I have this quote from Kitcher, where Kitcher in this 1953 and all that paper is very clearly saying, like, look, the questions that we want answers to in genetics, you're not going to get answers by appealing to physics or chemistry. There's just not the right kind of explanations at all. It's just answering a different question than we cared about when you start talking about those mechanisms. But at the same time, nobody is going to dispute that these are complex physical states and processes at the same time. All right, so that's all about comprehensiveness. I have a little bit more time, so maybe it'll be a little quicker than I was hoping for. But let's talk about the depth claim, because as I mentioned, this is a little more complicated. So the depth claim, so I say physics is fundamental in the sense that it provides ontological bases that are deeper, more comprehensive than that of any other science. So I said a little bit about what comprehensive means. What does deep mean? The reason why this is complicated is if we allow that physics provide ontological bases for all facts or entities, then it'd be very straightforward what this means to say physics is the deepest of all sciences. You would just say for any fact or entity, physics provides an ontological basis for that, and there's nothing else that provides an ontological basis for the physical. And then you would be done. It's the deepest. But that isn't the case. Physics isn't ontologically complete, and in particular, like I said, I want a notion of fundamentality of physics that even a dualist can agree with, right? Even a dualist who thinks there's a hard problem of consciousness, and they're not going to accept that current physics provides ontological bases for quality. So then the question is, then in what sense, if you concede that, or you allow that might be the case, then in what sense do you get to say it's established that physics is the deepest of all the sciences? So there are various ways that you can do this. I'm not going to have time to talk about this one, but it doesn't work. So I think, and I don't know, maybe another, so like the natural thing, I think what a lot of metaphysicians like to say when they're talking about depth, right, again, it's something is the deepest if it provides ontological bases for everything else and nothing else provides ontological bases for it. That's not going to work. Another thing you could try is you could try to say, this is what I call microphysicalism. It's like the picture that you had in Oppenheim and Putnam. You say physics is the deepest also because it describes the smallest entities. Right? So it has the description of the things at the smallest scale, and in virtue of that, it's deepest. So this is problematic for several reasons. So, I mean, before we even just start thinking about physics, I think one worry is if what you're trying to do is say, like, and this is the sense in which physics is deeper even than like a science of phenomenal consciousness, I think this is going to be a challenge because how do you, I don't know, I mean, I think it might be fun to fight about whether qualia are bigger than electrons. I mean, I don't know. We're not going to do that. So so that's already, it's just complicating. It's not clear how you're going to go forward there. Relating qualia and electrons, for example, in terms of size. But even setting that aside, I think if you're trying to capture a sense in which physics is deepest, that's like the sense Weinberg was talking about, right? When he was saying that it's the deepest, I don't think the right thing to say is that because it describes the smallest things. So for one reason, I mean, I just got finished with this big project defending wave function realism as a metaphysics for quantum physics. A lot of the metaphysics for quantum physics are not spatiotemporal at all. Wave functions aren't spatiotemporal. Vectors in Hilbert space aren't. Spin foams, causal sets. When you're looking at candidates for ontologies for quantum physics, very often they're not spatiotemporal at all. And yet you want to say those are candidates for a fundamental ontology. It doesn't look like we're getting, the more fundamental is always the littler, the smaller things. But also I think when you're thinking about within physics, and comparing what are the deeper theories versus the less deeper, the less deep theories, the contrast isn't really about size, right? The contrast is instead more like about the deeper theory being more fine-grained. And so what I want to propose is that, taking clues from, what in physics we want to say is a more deep theory than another, we should say that the deeper theories are those that are giving us more fine-grained or precise descriptions. And I'll just flag, one benefit of this proposal is that if you understand fundamentality of physics in terms of depth, and you understand depth in terms of the ability of the theory to give a more fine-grained, precise description, then you could see the value of having a more fundamental characterization in terms of the fact that it's able to give you more fine-grained handles on a phenomena that might allow you more exquisite causal control over it. So I like this kind of way of thinking about things. And so, then the idea here is, we're taking a clue from the relationship, for example, between thermodynamics and statistical physics. So, right, in classical mechanics, you describe systems in phase space, and every system will have a complete description in classical mechanics in terms of the precise locations and momenta of all particles at a time. And then we can look at, the evolution of the system over time as a trajectory, right, through this phase space. And then the less fundamental descriptions that we get, for example, in thermodynamics. So you don't want to describe, say, the gas in this room in terms of the precise locations of all the particles and their momentum at a time, but instead as in terms of their temperature or something like that, that's going to correspond instead to a region of phase space that's more coarse-grained. So this is the kind of model that I prefer. So when we're talking about depth, it's not a matter of grounding. And when we're talking about like not having a deeper ground, when we're talking about depth, it's not about, or that's not the definition. It's not about smaller. It's about this kind of giving a more precise, more fine-grained description. Okay. So just to conclude, I want to kind of just be explicit about how I think that is going to solve the puzzle case, where the puzzle being like, all right, how are you going to say that physics is deeper than like the science of consciousness? And they might still be scratching their head saying, all right, how is this really improving on things? Like, yeah, it was super confusing how or why you would even be motivated to say that physics is deeper than a science of phenomenal consciousness because electrons are smaller than qualia. But your proposal is saying that the science of physics is somehow more fine-grained than the science of qualia. How are you going to get to that conclusion either? It doesn't, I have a way. So this is what I want to conclude with. So, and I'm sorry, I'm rushing through here, but this is a starting point here. So I think the way that you can get, I think we can argue this. And the way to get a handle on this is just to start by noting, for very many qualia, perceptual qualia, those qualia correspond to observable features of physical objects. So to come back to Weinberg's piece of chalk, he talks about the whiteness of the chalk, right? And that's his first example of this is an ordinary observable feature of a physical object, and yet we can trace a chain of explanations ultimately down to the standard model of particle physics. So let's consider the whiteness of the chalk and consider the quale, the visual quale that you have when you experience that chalk. Okay, so let's start there. So call the white, there's going to be an argument on this slide. So we'll start by calling the whiteness of the chalk W, and now call the feature, the qualitative feature of your visual experience when you observe that chalk W star. Right, so here's the argument that the science of consciousness is less deep than physics. Premise one, descriptions of W and W star have the same fineness of grain. So if you want to know, want to get a better, more fine-grained description of your qualia, what do? You look at the objects that are causing the qualia, and you get a better handle on their observable features. Okay, so that's so premise one says the description of the observable feature, the whiteness, has the same level of grain as any description you'll give of your qualia. But as Feynman and Weinberg and Carroll were arguing, W, that observable feature, colors of physical objects have more fine-grained descriptions in physics. So since W and W star had descriptions that had the same fineness of grain, W star, the qualia, also has a more fine-grained description in physics. And it doesn't have any more fine-grained description in any other scientific theory. I think philosophers of mind, maybe that's, yeah, maybe that's wrong, but I haven't seen that. Therefore, conclusion, physics is deeper than the science of W star. So, you know, we need to generalize. So this is, I think, a reason that you can say that in general, any science of phenomenal consciousness, and that's kind of what we were worried about, establishing this kind of relative fundamentality relationship to physics, that science of qualia in general is going to be, on the basis of this argument, I think, less deep than physics. The reason why we're able to generalize is because I don't think that focusing on perceptual qualia was focusing on some weird rogue example. Usually when people are discussing phenomenal consciousness, colors, tastes, perceptual qualia are the paradigm cases. And so I think we can generalize this to say, in general, physics is deeper than the science of phenomenal consciousness simpliciter, not just the science of perceptual qualia. And then we can ask, well, could you give a more general argument going from there to say that physics is the deepest science that there could be, right? Any phenomena that we would want to talk about, the science of any phenomena we would want to talk about. There I want to say, no, absolutely not. I can't say that. All I think that we could say is that physics, and here I focus on physics in the standard model and general relativity, but I think it is a very interesting question, like what the physics is, what the current physics is that I'm claiming is fundamental. That current physics is the deepest of any of the sciences that we have today. But is it going to be the deepest science? All right, so conclusion. The standard conceptions of the fundamentality of physics that we see in contemporary philosophy, in terms of ontological completeness, can't provide a sense in which our current physical theories are fundamental. But that's okay. That doesn't mean we shouldn't say that physics is fundamental, and I don't think that means we shouldn't be physicalists. Because there's alternative conceptions of both the fundamentality of physics and physicalism that are available. In particular, when it comes to fundamentality of physics, that's been the subject of my talk. We can say that current physics provides deeper and more comprehensive ontological bases than any other science. And that is a sense in which current physics has a very special ontological status among the sciences. It's also a sense in which many physicists have claimed that their theories are fundamental, and that's good. That's like helping that claim to have scientific support. Earlier, I mentioned that one can use, I think that we ought to try to use the claim that physics is metaphysically fundamental in order to defend its social standing, right? So I think it's good to have an argument for this special social standing of physics that doesn't rely on, I don't know, warmongering or the assumption that like all we care about is, boosting the economy, but is really tied to the questions, the scientific challenges that are really most important to us. I hope that just based on how I've articulated what it means to say physics is metaphysically fundamental, it can be a bit clearer how the fact that physics is fundamental plays a role in explaining how it is that it can help address the challenges that are most important to us. And so that's because this claim boils down into these two parts. So there's the comprehensiveness part, and what the comprehensiveness part implies is that most of the phenomena that we'll be interested in have ontological bases in physics. And then the depth part implies that those bases are going to give us especially fine-grained descriptions of the phenomena that can, in principle, allow us to have more exquisite kind of causal control over them. So that's it. Thank you very much.
All right, plenty of time for question and plenty of question. Alex, want to start? Keep your hands up. Alex, want to start?
Yeah, thanks a lot. I like the project of finding a way to characterize fundamental whether your characterization, at least as the field in the beginning, is not too weak. So I was thinking about a mechanism in which everything like primitivities about colors, colors are primitives, that's nothing that explain them. The one that I see, primitivities about solidity, primitivities about value, primitivities in such a way that everything I interact with is really primitive, and physics is really interested in other things. And I guess that physics would be the only theory that is conclusive, because there would be an interesting theory of colors and theory of phenomena. But physics would still, it seems to me that physics would still be fundamental in no sense, but it wouldn't be very important because, I mean, everything we interact with is primitive and not explained by, I don't know if you see what I mean.
So you're saying, what if the correct metaphysics was one in which everything that exists is described by physics, but it's primitive?
No, in which there are primitive colors, like in terms of vivid colors.
We're just talking about color now.
Yeah, but also objects, objects that are like simple, and see the world that appears to us hidden. That's a good ontology. So a lot of primitive things that no theory will explain, but we still have the physics that works for non-primitive colors like wavelengths.
But how is physics going to count as fundamental in my sense, if that's the way the world is?
It would be the most comprehensive theory for all the rest
Oh,
of the
I see.
theory.
Oh, but it's still not very good. It's just it's comprehensive in the sense that it's more comprehensive than anything else, but it's still not so great. Yeah, that's not gonna be good. So well, I don't know. I guess I have to think about, maybe that would be okay. I have to think more about what the Edenic world would be. Yeah, so I guess what I'm trying to do in the second part of the book is where I try to say, like, here's the reason to believe that physics is deep and comprehensive in these senses. And then that's kind of helping me to be clear about what they are. In the comprehensive, I mean, this is related to the comprehensiveness part. In the comprehensiveness part, I'm actually fine to say that it doesn't really provide complete explanations of I mean, even of the phenomena where, we're kind of making these inductive, when we're making this inductive argument, these micro-reductive successes, I mean, another, I think, good objection to Oppenheim and Putnam and Melnick is that these micro-reductive successes aren't really as successful at explaining everything as much, or there, I mean, philosophers of physics want to object to some of these steps. But I do think that for phenomena and color in your example too, you do get some kind of explanation of some aspects of these phenomena from physics. And that might be enough. That kind of comprehensiveness might be enough to get us what we want. I mean, ultimately, like at the end of the day, it's like, what do we want out of this claim of fundamentality? And I think, right now when we see surveys of people, so like the World Economic Forum did a big survey, like what are the most pressing scientific challenges over the next 5 or 10 years? It's always like climate change, big change in weather patterns, this and that. And you want to look at these problems and say, like, how can physics help us with that? I think even if it is the case that we get some kind of explanations of weather systems or something like that, a partial ontological basis, that's the kind of language that I use, falling confined, for these phenomena out of that comprehensiveness claim, I think that's still giving us something extremely valuable. But yeah, it might not be everything.
Hi. Right.
Thanks, Alyssa. This is really interesting. I'm curious if you have a favorite definition of physics, or if a strict definition is too much to ask for, one or two kind of characteristic features that are distinctive of physics versus chemistry versus biology versus any other science. Because you set up this comparison between physics and other sciences.
Yes.
So thinking through all this, I'm wondering, what is it about physics here that matters? And in particular about maybe theories of physics that aren't the ones that we point to throughout here as fundamental physics. So things that aren't quantum field theory and the standard model, that aren't cosmology or DR, that might be amenable to at least the comprehensiveness claim you want for physics. So me, especially applications of biophysics, like the genetics example. Maybe there actually is something that physics can do for our understanding of genetic phenomena, but it's not going to be from QFT. It's going to be from biophysics applied there in the proper way. So as I'm thinking about it, it seems to me that what makes the comprehensiveness really work for physics across all the theories of physics is the characteristic feature of abstraction and getting it universal things that then makes physics so applicable across all of these phenomena. That seems to work for comprehensiveness, but not so much for depth. So just briefly, the other example that comes to my mind is like fluid dynamics, as again, not small scale microphysics, but applicable at these mesoscales. And that fluid dynamics applies and is important for our full understanding of something like the flow of blood through the body. But we have to fill in the more detailed descriptions of what's idiosyncratic or specific to blood flow from organic chemistry and from biology, and physics is going to give us depth in that case. So what do you make of those different theories within physics, and what does that do for your definition of physics?
Yeah, so I've been kind of working on this. I mean, I wanted to give an account of fundamentality that can apply to actual 12 theories that are incomplete along these lines for a while. And I've gone back and forth about, I mean, there was a point where I was saying to myself, like, I'm going to just have to say condensed matter physics is fundamental or something, and then that's it. But I've decided actually in the book, no, I don't want that. I'm just going to try to push this case. So you can, what you're saying is very interesting and important. This is kind of what I'm grappling with in the last chapter. But what I'd like to do is try to make a case for a standard model. In order to say, like, at the end of the day, we should keep funding high energy physics. And I want the fine grain, but yeah, I mean, this is the kind of problem, because then when you start connecting the characterization of the more precise characterization of fundamentality to the actual problems, and you see, this is why physics is useful when you want to predict when there's an extreme weather event that's going to happen. It's not really, yeah, it's like what you're saying. It's actually, yeah, I don't know. So I'll tell you what I say, why I do think the fine-grainedness, the depth in my sense is important. The case study that I have is looking at, like, when there's going to be an extreme heat event or like an extreme like rainfall or flooding and stuff like that. And in those cases, climate scientists and meteorologists, and it's coming from like both sides, are saying we really need to have more precise initial conditions and carry out the equations. So that's why I was saying now, it's not at like super small scales of the standard model. I mean, the scales are like a kilometer. They're like, it would be really good if we could like say what's going on in like a kilometer. I'm putting it like this is not to scale. But it's still precision. It is precision. So that's why, yeah, I was thinking maybe this does work, and the sense of depth really is important, because they're really saying, like, it's not, this isn't the only thing we care about. It's not saying, oh, so stop, model, stop these other kinds of methods of predicting change in climate science or anything like that. But it's saying for certain purposes that are super important, we do need the fine-grainedness, and that's something that you get in physics. So I thought that I actually could make that connection, but I don't need to say that it's universal. I don't need to say that also this is the only reason why physics is important. But I think it's, yeah, I think you pushing me on this is useful, because, yeah, I should think more about how what you're pointing to kind of fits into the case. And so thank you.
Yeah.
Thanks. I have a lot of questions, and just to pick one. When you talked about depth, you were mostly talking in terms of description rather than explanation.
Yes.
And that made me think that although physics does give very nice and fine-grained descriptions, in a sense, mathematics is deeper, and it actually gives us tools that can be even more fine-grained and precise. And very often, physics progresses because mathematics provides further fine-grained wisdom.
Okay, yeah, so, in Comte's kind of order, hierarchy of the sciences, it's mathematics. That's the most fundamental, not physics. So the most fine-grained description, I mean, like, so can you give me an example, like what you had in mind? Because I mean, physics is written in the language of mathematics. So, did you have in mind, like, there are multiple mathematical descriptions you could give of the same phenomena? So in that sense,
that's one
okay,
yeah.
So like I had so you could think about.
And sometimes they just build in further grain and structure. And like when you put a fiber bundle over what you thought was just a simple space-time.
Well, that's really, yeah, oh, that's really interesting. So when I shifted to the talk about, yeah, so you know why, I mean, the reason why I shifted to talk about descriptions was because I just thought it felt like a category mistake to keep on the material level, kind of at that there. Yeah, I think about that. Yeah, I have to think about how I want to respond to that. So I'm not thinking that that's fine-grained in the same sense, but I don't want to beg any questions. So yeah, that's a really good question, Carl. Thank you.
Yeah, last question is also about this concept of
Yeah.
because we could have fine-grained and exact descriptions, but that description might be irrelevant to the phenomena that we have. For example, at other levels, like, for example, psychological level or biological level or
Yeah.
ethical level. For example, we have an ethical issue about the behavior of someone, and it's about whether it's good or bad. And so we could have a physical description, which is more fine-grained and exact, but it's totally relevant. So
Yeah.
that's the importance of relevance to that. Because if we have fine-grained exact descriptions, but not relevant, so in a sense, the relevant one, but less fine-grained one, is more fundamental, because that's the description of the phenomenon.
Yeah, no, absolutely. So, I mean, that's so that's something that I want to accept. So, just in the interest of time, I didn't go into detail with in the comprehensiveness part about, the kind of examples that the anti-reductionist philosophers of the special sciences that I was characterizing were using. But I mean, that's like Putnam's famous "why won't the square peg go into the round hole" example is, exactly making that point, that for many purposes, when you bring in the kind of microphysical details, you're now distracting from what the important question is that you're trying to address that requires you to abstract away from it. And this is related to my explain also, like, so I want to completely agree with that. I'm not saying for all purposes, this is the right thing that we should do. I'm not saying that we shouldn't have biology and psychology, we shouldn't have the special sciences. There should only be physics. All I'm trying to say is that for certain purposes, and including purposes where you are interested in phenomena that are in those other sciences proprietary domains, there can be value in a physical description also. And so I mean, the example of predicting, exactly when you're going to have an extreme weather event is an example here. I would want to say for many purposes in climate science, you don't need to have such a fine-grained description of what's happening. That's going to be irrelevant. But there are other purposes in which it is important. And I mean, I don't have and case studies off the top of my head for, I don't know, to talk about that in the case of psychology or economics, but I think in many cases that's going to be the case as well. So in general, I think you're right. You don't want this kind of fine grain. The question, all I'm trying to say is for some purposes, it is important. And then I think what we need to do, or I mean, what I need to do, but maybe if other people want to help, they could also, is provide cases where it's like, this is an important problem. And you might think physics is totally irrelevant to this. But actually in this case also, the fact that physics gives you a very fine-grained description of what's going on and will let you evolve the system forward to say exactly what you're going to have here is useful. I mean, in situations where you have chaotic phenomena that are very sensitive to initial conditions, that's any kind of case like that is going to be.
John.
I want to offer another reason for why I think physics deserves some sort of status in society.
Oh, great, yeah, let's.
And it's one that you already know, but I think it's important. It's just that the physics itself has an intrinsic merit for us as human beings. I think of it as something like art, right? We fund art, we teach art, because for many people, this is what makes life worthwhile. It is an end in itself. This is what feeds a soul. I see the same in physics. It's true for me, and if you'll let me tell a story, I just want to tell a story, right? Because it'll help. When I first realized I wanted to get into philosophy, I had no academic appointment, whatever. But I was just reading around, and I was reading philosophy, and I liked it. And there were two things in the whole universe of ideas that grabbed me. One was the idea of consciousness. Right? I was just completely fascinated by the thought that what you would otherwise imagine to be inanimate matter could somehow be conscious. Absolutely intriguing. And then, of course, stuff going on in physics. So I did what we had to do in those days. This is before the internet, so we had to get these things known as books. And so I got a book in psychology because I wanted, I wanted to understand how is this magic of consciousness? How does this happen? And of course, you can figure out exactly what happened by reading this book in psychology. I think it was a book on personality theory in the end, and it was okay, but it didn't do anything for me. And then I got a book on relativity, and that was extraordinary, right? It became clear that there was a huge world of absolutely fascinating ideas out there that had to be explored, that had to be opened up. I've been doing this work for many years, and when I tell people, oh, I worked on, Einstein and relativity, they light up. Not all of them, but enough of them do. They light up. Yeah, some of them.
Well, that's a question. Enough of them? Do enough of them light up?
They do. It's a repeated phenomenon, and there's this deep sense that it just has an end in itself. It's got nothing to do with it being fundamental or otherwise. So anyway, that's
no, not anyway. I really want to pursue this. I think you really. So I don't know. Do you really think that that's enough to justify? I mean, making teachers learn it, to be spending all of this money on these neutrino experiments and this and that. I mean, I'm just.
You said, do I think it's enough?
Yeah. Do you think that that's enough of a justification that you light up and everybody else lights up? That you talked, or sorry, not everybody, but enough people.
I didn't say it was enough.
Okay.
I said it's a major factor. I told the story about me.
I'm asking that seriously, not to argue.
No, I understand. But it is the case for me. That's why I do philosophy and physics. I didn't say I want to get down to the fundamentals of everything. It was just, wow.
Yeah.
What do you mean? Gravity is a curvature of the geometry of space-time? What can that possibly mean? Now, of course, if they had no answer, as is the case with consciousness, I would have run away. But no, there was an answer, and it got deeper and deeper, more and more interesting. Art doesn't work for everyone,
right?
And I don't know that fascination with physics works for everyone, but it certainly works for a lot of people.
Yeah. So I mean, this is part of the story. This is part of the story, but just like. So this is the last chapter of the book where I'm trying to connect this, and also part of the story is security, national security. So you might say, I don't want weapons so I can attack other people, but at least I want to protect myself. And you can get very easily to justification for wanting people to learn and understand physics that way too. So there are other justifications. I'm not happy ending with this kind of justification, even though, yeah, I mean, this is why I was interested. Okay. You just want, no.
Siddhas. Thanks. I wanted to ask whether you can formulate your core claim a little bit more neutrally to metaphysics. So if sort of your proposal, you could just say that physics offers more comprehensive and
deeper explanations or physical theories are more comprehensive or deeper theories than any other theory. But then sort of once you put it that way, then if you sort of drop out the language ontological bases and metaphysically fundamental, I feel like that's even more sort of has less baggage, so more likely to be convincing to people who might be skeptical of sort of deep metaphysics.
Yeah. I totally agree with that. So yeah, I mean that is what I do in the book. I mean I default back to this statement that it's metaphysically fundamental in the sense that it provides ontological bases, but officially I want to be more neutral. And so if instead of saying, so the examples I gave of how you might clarify what that means is, you know, supervenience bases, grounds, realizers, but you could, if you want to talk in terms of reduction, like Hegelian reductions or something like that, that's fine also. So I'm officially neutral about all of that.
But is there a reason why you wanted to sort of?
But in terms of ontological bases, yeah, I mean the reason why this is like my more default characterization is because I want metaphysicians to develop this and not just keep continuing to talk in terms of ontological completeness. So this is their talk. They talk about ontological bases, and I want to say this is an important sense in which physics is fundamental. Most of the time, when you write this isn't a complaint, we're all esoteric at sometimes, but when you write your very esoteric papers about fundamentality, you're motivating them because it's something we care about. And it's usually like physicalism is the first example. We're trying to understand the sense in which physics is fundamental. And so I want to say physics isn't fundamental in that sense, but this is getting closer to what the right sense. I know I'm not confident about what I'm saying here, but I think this is more on the right track than the ontological completeness conception. So yeah, I don't know. And also I'm a metaphysician. I like grounding. So I'm like perfectly comfortable with this kind of talk. But if you're a logical positivist, you can do this too.
Just one quick follow-up is that if you're intending that statement to appeal to metaphysicians, then they will just say, well, what you provided is just a notion of relative fundamentality. That you've just argued that physics is more relatively fundamental than other theories.
It's that would still be interesting. It's more fundamental than all theories that we have. So, yeah.
Please.
Yes, thanks for your talk. I have a question about your argument where you argue that physics would have to be more fundamental than a possible science of phenomenal consciousness. So one premise there was that the physical fact that an object is white, as well as whiteness, has the same depth, or is as precise as the fact that we possess a phenomenal experience of whiteness.
Yeah.
And I want to ask again about why that's true.
Yeah.
Because if these two facts are in different categories or are related, it seems difficult to argue that they have the same procedure.
Yeah, so the motivation is coming from this paper that Gilbert Harman wrote called The Intrinsic Quality of Experience. He was defending representationalism there, but I argue on the book you can come up this different ways. You don't have to be representational. So he had this example where he's like, you know, you're looking at a tree and you want to better understand your experience, your visual experience of the tree. How do you do that? If you want to understand your visual experience, your character of your visual experience of the tree, you definitely don't close your eyes, right, and turn inward. That's not going to help you. If you want to understand the quality of your visual experience of the tree, you turn outward. and you look more, keep looking at the tree. So the idea is that visual experiences are transparent, and that will lead to representationalism, but set that aside. I'm happy to talk about that if that concerns you, but that was the idea. So if you want to like get a very fine-grained description of your experience, the way to do that is by getting a very fine-grained description of the observable feature of the object. That's what it's motivating.
So I've used my power as a chair to ask a follow-up question.
Yeah.
So I think it works quite well for vision. Indeed, it's not an experience that you mentioned. Man's paper works less well for audition. Works quite poorly
Really?
for pen.
Oh no. Well, okay, pain, fine. But can you say about audition?
Well, I'm not quite sure what I should be paying attention.
Well,
I'm not exactly sure where that is really. So it's very spatially vague. I'm not saying it's totally. I think audition is a bit of an intermediary case between vision and.
okay, so if somebody's playing the cello and you're hearing these notes and you're trying to, it's difficult.
What are you paying attention? You're paying attention to the visual object, the sound.
The sound, yeah, it's an observable feature of the bow, the strings.
I'm not sure the sound is an aspect of that. Maybe the sound is a property of the event. Okay, maybe. What about pleasure and pain?
Yeah, so right. So there's a controversial way to get
to
it, but I'm not going to do the controversial way, where you say that your representation is about pain, but so I don't. So right. So in those cases, I don't run this argument. I'm not going to run this argument. I run this argument about perceptual qualia, and that's why I was interested more in the audition case, because I want to run this for perceptual qualia, and then say perceptual qualia. What we say about perceptual qualia, we should say about all of them. So and I can't see any reason why you would say our descriptions of pain could somehow be more fine-grained than our descriptions of a visual quality. For me, I'm just going to say, when you go to the doctor and all they ask you is put it on a scale of 1 to 10. I can't do that ever. I get very uncomfortable and I'm like, I don't know, or when you're at let me not go there, but it's hard to, I think if you can convince me that somehow we have more fine-grained, precise characterizations of our bodily sensory qualia than we do of our perceptual qualia, then I want to hear it. But to me,
we'll talk about that later. There's a small literature, you're right, where quite a large literature in philosophy of perception arguing that indeed our concepts of these perceptual experiences are not very fine-grained. But of course, you can have deictic references to these experiences that are extremely fine-grained. So you can distinguish, so you can discriminate like pain experiences. Now they don't fall under a concept.
That's a good point.
But they fall under some kind of deictic, right? And that can be extremely. So I'm not sure whether that's going to be right.
Right, because I want to say we can, if we're talking. The chalk is a bad example, but like that chair or something, the color of the chair. I don't have a word for that.
Exactly, yes. That's right. Exactly. Yes, correct.
But whatever I'm going to give, so I'm going to use a perceptual demonstrative to get at both the character of the visual experience, but also the color. It's that color. And I think it's the same. Yeah, so we use these perceptual demonstratives, but they apply in both cases. And so to say that a perceptual demonstrative that picks out a quale is somehow getting a more fine-grained description than anything, of an external world object, I don't know.
To be good, you go for it.
Okay.
No, yeah, you have a question too? And go for it. Yeah, go for it. Yeah.
Oh, thank you very much. So I was wondering the physical theories that actually fit in these arguments about comprehensiveness that are part of what we call physics, right? Like particle physics maybe, or microscopic physics at least. Because if you think about the objects that's being studied in astronomy or even classical mechanics, it seems like at least chemistry is more fine-grained than chemical objects are more fine-grained than objects studied by astronomy. So it seems like part of some physical theories we have cannot fit in. They cannot be at the bottom.
Yeah. Yeah, I think that that's probably right. Yeah, so I think you have to think, so I'm open to the claim that different people, if they want to defend the fundamentality of physics, will want to defend the fundamentality of different paradigms, right? And so here I kind of settled on, yeah, I'm going to talk about like what Sean Carroll calls a core theory, and that's the standard model and general relativity. And so it's not all quantum, but yeah, it's not going to be all physics that I'm trying, for which I'm trying, that I'm characterizing here as fundamental. And yeah, I don't know if that's the right strategy, but that's what I decided to do. So yeah, that's just, yeah, yes. Yeah.
Thanks. Very quickly on three, and then
Yeah.
if you're a panpsychist,
Yeah.
that would look like.
No, I think it does.
If I think my consciousness is composed more into like smaller conscious bits and then.
Yeah, but they don't have, that's not science. No, I'm
I'm
serious. It's not science.
I would have a more fine-grained description in my consciousness studies, right? So I'd start with a more fine-grained.
Okay, so I mean, Philip Goff, you know, wants us to, you know, pursue science that takes these things to be like, you know, qualia to be more fundamental than electrons and mass and charge and whatever. But that's just like that's his agenda, and he's like, let's do that, and you know, that's fine, you know, go for it. But we don't have that. That isn't an actual science that we have, where we have like confirmed, you know, we have predictions, and then we have something established. So that's why it says any current scientific theory.
The more substantial question, when we're thinking about this sort of justifying future fundamental physics research, there seems to be a promissory note on future physics also continuing to be unified in sort of the Washington triangle sense. That seems to be, I accept that to be the case, but I don't know what guarantees that.
You do?
That needs to be guaranteed for future research. So that needs to be guaranteed in order to justify future research. Then what seems to be called that?
I don't want that. That's not part of what I'm trying to defend. So sorry, I don't want that. I want that, but that's not part of what I'm trying to defend. So I'm really like, I mean, that's part of what I'm trying to push here. It's like, I don't know what's going to happen with physics, especially right now with the, you know, role of machine learning and fundamental physics, and we're at a transitional period. I don't know what's going to happen. So all of this is supposed to be a claim about current physics. So this is why I'm like very, you know, in the beginning I said there are obviously so many, you know, philosophers who want to say physics is fundamental. I'm a physicalist because I believe there will be a final theory that's complete and describes the ontological basis of everything. And I'm like, I don't know if that, I don't know if that's true. I don't know if, yeah, physics and you know, what physics and 50 years is going to look like. So it's really tied to a claim about physics we have right now. So I understand why you're asking me this, because I'm talking about like funding projects, finding new theories and things like that. But you know what we're doing right now is working within a paradigm, is working within this paradigm and trying to, and teaching it, and we're testing it, and we're trying to see where it breaks down. And so that's what I'm defending. Like I'm trying to explain what makes this paradigm so special. And I think that it's like super interesting question, you know, what's going to happen in the next, even 10, 20 years. But this is explicitly, because we don't know what it's going to look like, I'm trying to, or that's one of the reasons, I'm trying to defend this paradigm that we have now, teaching it, developing it.
You're fine.
So the
Yeah.
the sort of history that you gave at that moment where we were referring to as the debate between him and another part of this, and that's not just about like the American Party.
Yeah.
And so I was wondering what you want. So there's like one of the mathematics saying sort of against this idea. I don't know if you've read.
Yeah, the emergence of
The
merge, yeah.
But
Yeah.
I also never know if I said it
Oh, sorry, I don't either. I wasn't critical.
Yeah. So no. Anyway, so let me try and see if this is like sort of more subtle than him saying like, you know, particle physics is not fundamental because like particles. I think at the time it was more like I mean at the time it was maybe so close to finding this one super important thing. That's not really probably like they're just going to find something else and then they're just going to want to find more after that. So there's no real reason to think that. So that's one thing. But then the other thing as well is that I think he's kind of arguing the physics, current physics, even though he's trying current physics is telling us or is giving us this picture that like doesn't really allow for there to be a thought at any. So he's arguing that sort of this that like metaphysics is very similar to what we do in physics, which is kind of like, you know, whenever you see disturbances, you just redefine the vacuum, one level below it, and then the new thing is the new particle, and then you just keep doing that. And so he's trying to argue that like current physics is basically telling us that what we're saying is just a certain amount of layer. So I mean, I feel like that's sort of, it's still kind of the same as like we're not at rock bottom, but he's trying to say more of like the physics that we have right now is trying to tell us that there's sort of it's increasingly futile.
Yeah, I mean that's really interesting. Yeah, that's not what I was talking about. I was talking, I mean, it was more Anderson that Weinberg is engaging with there, where Anderson is saying like, no, condensed matter physics is fundamental, and you don't have a way to say like, you know, particle physics is more fundamental, and then Weinberg's like, no, but we say it because it is, and that's so it was a little maybe like 10 years earlier than this kind of, but that's super interesting. But that's all I want to say, I don't know how to read. That's compatible with what I'm trying to say. So I'm trying to say we can say that current physics is fundamental and not say it's the rock bottom, but there won't be something more. But I don't know. Yeah.
Compatible with the idea that like it's intrinsically futile.
Intrinsically futile.
But that's kind of very, I don't think that's, it's a very extreme of what he's trying to say. I think that.
I'm not defending, I'm not saying that physics is the physics that I'm talking about is fundamental in the sense of which it describes the highest energy scales or the smallest length scales, that it's deepest in that sense. And I'm not saying that it's valuable in getting, and that we should be, sorry, the reason why we should be continuing physics is because it's letting us get deeper. I'm saying that it is giving us extremely fine-grained description. So there's a slight difference. I mean, but it's a very interesting question. And I want to, I'll think about that kind of way of putting it. But I'm kind of feeling like it's not the argument that I'm making, but yeah, thanks for reminding me about that book. And yeah,
It's only 5:21, so we're gonna have to wrap up quite soon. Andrea, go for it, and then there's a few hands that I get, and then we go for it.
Thanks. So very quickly, I was wondering, would you say there are fundamental entities? And if there are fundamental entities, why are they? In what sense are they fundamental? And would you say that what is fundamental is fundamental because it's there from the beginning of times, or can fundamental things appear in time? What would you say?
Yeah. So in metaphysics, a lot of times, fundamentalists apply to entities or phenomena, properties, and that's not, so in a sense, I'm changing the subject because I'm really trying to talk about theories as fundamental. I'm not the first person to do that, but that's what I'm trying to do. So I'm trying to characterize a sense in which physics is fundamental, that takes on board the lessons of the anti-reductionist philosophers, but doesn't just make physics another special science. I don't really feel comfortable with saying that entities are fundamental, at least in this sense. If you want to define a sense of fundamentality as like ungrounded or something like that, then I'm not going to object that there are certain entities that are or are not fundamental in that sense, but it's not really this kind of interpretation of the fundamentality of physics that I'm defending here. I don't think it doesn't really make any sense to
That's why I was
apply it
wondering
to
about the
entities. Yeah.
All right, thanks.
Yeah.
That's right. Yeah.
I'll give you the convention as my question. When do you think physics?
Oh yeah, that's such a great question. I mean, not a great question for me. I'm not. I probably can't answer it. But like, yeah. I mean, that's. I like that because it's like, yeah, I'm not. Physics now is fundamental. Is physics right? This is the definition of fundamental I have in mind. It wasn't always fundamental, and I don't think it's always going to be fundamental. At least anything that's recognizably physics, right? At some point, we're going to have something that doesn't look at. This is where the crazy part of the talk, or the Q&A. At some point, we're going to have a scientific theory that doesn't, I think, that looks no more like current physics than Aristotelian physics looks like current physics. And it's going to be really, really successful, and maybe it'll satisfy this. But I wouldn't say it's physics in as much as I wouldn't say Aristotelian physics is physics. So, when did it start? I don't know. I like the paper by David Papineau called The Rise of Physicalism. So yeah, maybe I'll go along with him and maybe say, in the 1950s or 60s. Yeah, let's say that.
My question relates back, I think that's your question, really, but usually the more like fundamental or mindfulness within most in a lot of cases, yes, or
Yes.
or even explanation.
Yeah.
I was wondering that if you think it's relevant that on some level, once you get to a level of time, it's almost like not only does it not give an explanation for the now, give an explanation, meaning what I mean by being like you're wondering figuring out to the problem level, you're never going to be able to like represent that in any way. Not even like you can't have knowledge modern they cannot exist
Yeah.
that. So particularly in the sense that the Olivia is active theories like they are bad ideas, but I think it's relevant that they're sort of at the point effective theories are sort of no longer effective and they sort of don't have any more predictive relevant at that point. Because it's anymore sort of like at that point it really is science that you haven't find this really positive again.
Yeah. I mean, I just want to, I think it's important to concede the limitations of physics. I mean, I'm trying to, but I don't want to over kind of, I agree with what your concern is and what Marion's, I agree with all of these concerns. I just think that I want to spend more time kind of promoting the successes and where they can be, where it can be useful also. But I think that since there was more philosophy of science, there wasn't just philosophy of physics, we've come to acknowledge that, this kind of more and more fine-grained theory isn't always helping us with all the problems that are very important for us to understand all the explanations that we want. But I think it's kind of more interesting to try to figure out when a super fine-grained explanation is going to help us. I don't know, that's more my project now.
Louis, there's a last question.
If I raise my hand immediately after talk and as I understand it, it was instructed as that I will name to the code, so I'm not going to waste anything.
So, what you have a question?
Yes, I have.
Why don't you ask your question?
But first, I always had a confusion that I think his name is Carl, but I thought you called him John.
Carl, why don't you ask your question?
Yes, I have. My question is similar to Marion's. What is physics in your understanding? Let's suppose we can have two theories about transubstantiations. We can have one theory that transubstantiation only happens with unliving bread, and in second theory that transubstantiation only happens in living bread. And the theologians would clearly argue that they're describing a physical process. They argue that they're not discussing a metaphysical process and not, it's not abstract, it's not a spiritual process. And so in that case, we have to compete physically.
Oh, transubstantiation?
Yes.
I'm not calling any of that physics.
Yes. So, but why that's not called physics? And so why, what's this distinguishing physics from non-physics?
Okay.
They claim that physics is not about something about spiritual.
Yeah, right. So that's not good. Yeah. So this is something I talk about and a lot in the first chapter of the book. So I don't want to try to give an account of what this is a problem. The reason why I talk about it in the first chapter is because this is a problem you get into when you try to say that you're a physicalist in the sense that you believe that physics provides a complete set of ontological bases for all facts or entities. You have to say in what sense that complete theory is physics. Because you don't have a theory to point to and say, it's that theory. You're talking about some hypothetical physics that we don't have access to. I don't have that problem though, because I'm just talking about these paradigms that we have that are actually developed. So I can just point to like the physics department. I don't know where it is, so I'm just going to point over there. Right? Okay, wherever you guys know where to point better to be, point there. What they're doing, that's what I'm talking about. And I don't have to, right? Because I'm talking about current physics, and I don't have to worry. And then you say, oh, but that's not complete. That doesn't provide a complete set of ontological bases. And I say, I agree, it doesn't. That's not what I'm talking about. So, so for me, yeah, no, I mean, it's a great question, but I'm not trying to give any kind of a priori characterization of physics. And I definitely wouldn't say what makes physics physics is it doesn't talk about anything spiritual or mental or anything like that. Because I think a lot of, sometimes people have interpretations of quantum mechanics where they're observers and they're fundamental and we can talk about this more, but yeah. But that is a problem. You get into something.
Very good. Thank you very much for going in for nearly 1 hour. So thanks for your the 11th floor. We have a reception following this talk. So please join us to the center for some food and some drinks and coffee and whatever. Right, thank you very much.
Oh, thanks.
No, just, yes, we took 2 hours. So.